Hi there, this is a video for section 1.1 on finding the values of functions using equations, graphs, or tables. Example I'm going to be demonstrating right here. It uses three different functions. The first function is written as fx equals negative x squared plus 8. That's a function written as an equation, the most common way to write a function. But we have a second function here, g of x, that's written in terms of a table. It is actually quite common also to write functions as tables. So be aware that this function is written not using an equation, but using a table. And lastly, we also sometimes see functions written in graphical form, which means a graph is given of the function. So we can now calculate different function values, and I have some examples right down here. Feel free to pause the video at any time to see if you can find the answers to these questions. It's great to try them ahead of time and then compare with the way and strategies that I do the problems. That's a great way of actively learning how to do things. Well, welcome back. If you did pause the video, I'm going to be going through the answers for A through F. For the first one, F2, it refers to the F function. Functions are going to be written in letter parentheses letter format, F parentheses X, the one used most often, but we could do F parentheses T or G parentheses X or any letter, comma, letter parentheses, comma, letter parentheses combination. So F2 refers to the F function, and in place of X, I have 2, so I'm going to be substituting 2 in for X, or I'm making X have a value of 2. So in this case, since it's given in this equation, I'm just going to plug in the 2 or substitute x equals 2, just like that. All right, so this, I use parentheses very often just to make sure that it's clear what's being squared, what's being negated, to do the order of operations correctly. You don't have to use parentheses if you don't want to, but I definitely recommend it sometimes because it is helpful. All right, so according to the order of operations, I square first, then I negate, and then I add 8. So the value, the function value f2 is equal to, well, that's positive 4. Negative 4 plus 8 is positive 4. Okay, there we go. For g2, that refers to the g function, which is this function in the middle given as a table. So I'm going to be referring to there. There's nothing to plug in for 2, but it does specify that x is going to be 2. So I could just look on the table. There's where x equals 2 in the x column, and that gives a function value in the y column or the function column of 4. So I can say g2 is equal to 4, and that's just from the table. I don't think it's possible to find an equation for this particular table. Even if you could, it's not necessary. You could just look on the table values and know that the y value is 4 when x is equal to 2. H of 2, which is problem number C, or letter C, refers to the h function, which is our graph over here. So for the graph, we want to make sure that we can find when x is equal to 2. So if we look on the x-axis, I'm not sure what your screen resolution is, but that's where x equals 2. And if I follow up to the picture is the graph, the line, not the axes. That's not the graph. The graph is this, red thing, if you're color sighted, that goes sort of down. So we go up to the graph, and then we look at the function value at that point, and that appears to be 1. So I get h2 is equal to 1, and that's just from the table, from the graph. And I've also marked on the graph the value of 2 and that it equals 1. So I'm kind of showing my work on the graph itself. All right, question D, F4. That goes back to the F function. Once again, remember to pause and try things. So if you didn't pause for A, B, and C, maybe now pause for D and F. All right, so for F4, I'm going to plug in the 4 value into the F function. The F function is written as a equation. So I'll plug in the negative, I do 4 squared, and then I negate that. And then I add 8, and negative 16 plus 8 is, in fact, negative 8. G4, I'm going to be looking for 4 in the G function when x is equal to 4. And I can read off that G at 4 or G of 4 is equal to 2. That's just from the table. And lastly, H4, I'm going to have to find 4 on the H graph. It's right here. There's no going up or down because the graph actually has an x-intercept right at 4. So right there is what happens when x equals 4. That is y equals 0. That's called an x-intercept. So just to also give as an aside, tables and graphs are limited. So if I was asking for the value of G6, there's no x equals 6 listed on the table. So, whoops, that says x, doesn't it? If I was asking for the value of G6, 6 is not listed on the table. The table stops at x equals 5. We don't really know what the value is going to be. Even if we could try to find some equation, that still might not be the right equation. So we say G6 is undefined. We have not defined what the value is at 6. And likewise, we could say that H6 is undefined because the graph doesn't show us when x equals 6. We could try to, continue the graph, and we could actually get a pretty good approximation. We could perhaps approximate, but we wouldn't be able to find a precise answer. Most answers are approximated anyway, and I'm afraid the approximations get worse and worse the farther you expand upon the domain that's given for the function. Of course, with equations, you can find F6. F6, like any number you could just plug in. You could definitely do that one. So that's kind of an extra bonus fact about equations, tables, and graphs. Hopefully you found this video useful. Please reach out if you have any questions or comments. Thank you.